At peak hour, a busy city intersection looks like total noise. It's a blur of weaving cars, shifting weather, and erratic movement that seems to have no center. But if you track the timing of the signals or the way vehicles group into lanes, the mess starts to dissolve. You're seeing the underlying framework, the consistent, repeated sequences that keep the system from collapsing. These sequences are patterns. They are the regular, predictable rhythms that bring order to raw data. This image highlights how we organize language into these predictable structures. You can see the repeating alphabetical groupings of C and D that give poetry and songwriting their rhythmic beat. We see these same sequences structuring the natural world, from the tight Fibonacci spiral at the center of a sunflower to the precise V formation of a flock of migrating birds. Our brains are hardwired to hunt for these sequences because they offer one specific advantage: predictability. When we spot the repetition in the past, we remove the guesswork from the future. We can finally anticipate what happens next. Finding these sequences starts with simple observation. We watch our surroundings and take mental notes of what repeats over time. Take a weekly basketball game. If you practice an hour every single day, you will reliably score more points. The cause and effect are clear. Break that routine by skipping practice, and your scoring drops. The rule holds true in both directions. That mental math works perfectly for one person tracking one sport, but try scaling up to millions of data points across global supply chains or weather systems, and human observation hits a hard limit. As the scale of our world's data outgrows what our eyes can track, we are forced to invent much larger systems to find the hidden rules. We impose order on massive data sets using intermediate tools on the left, translating numbers into bar charts so our eyes can digest them. But when data becomes too dense for a graph, we turn to machine learning. This flowchart maps exactly how AI processes that volume. On the far left, raw data enters a system designed to isolate similarities. In the center, an automated agent cycles through a continuous learning loop. It interacts with its environment, using a reward system to select the best algorithm for sorting noise. On the far right, the system pulls perfectly organized clusters of information straight out of the raw chaos. Artificial intelligence is simply a scaled-up, mechanized version of human observation. It is built to find the patterns our own eyes could never see. Which brings us to the critical question. Once a human or a machine has finally identified a pattern, what actually happens next? We draw a conclusion. We figure out exactly why the pattern happened and what broader rule it teaches us about our environment. Merely identifying a trend is entirely useless if you leave the data sitting on a hard drive. It only matters when you apply it to a real-world problem. That application is the final step of the computational loop, decision-making. You do this naturally. You observe the visual pattern of a dark, cloudy sky, remember that it usually rains, and decide to carry an umbrella. A navigation app does the exact same thing with data. It observes historical traffic patterns, identifies a delay, and makes the proactive decision to route you down a quieter, faster street. That is the true measure of intelligence, whether human or artificial. It is the ability to observe the past, recognize its patterns, and use them to command your future.